Chapter 3. In this chapter, we take a look at the enterprise architecture. And why this is important is we can have all these nifty, neat technology tools to use, but somehow we have to be able to interconnect everything together. We have to be able to communicate between people, between systems. How do we take advantage of all this digital technology? We have to be connected. And so that's really what this chapter is talking about, is how do we accomplish that in business? So the first thing to talk about is the storage. With all this data and information and other reports and stuff going around, how do we store it? Well, the primary storage in most applications, it's a temporary storage, what's called RAM. This is a solid state component that exists in computers, it exists in servers, and the information that's stored there is only, valid. It's only available when there's power and the system is running. When you turn the system down, when you restart or do a reboot, all that goes away. That's just temporary storage. And the reason that it's temporary is for speed. By having this random access memory, the system is able to access the information very quickly. If it used permanent memory, it's a slower response time. So to get the fastest response we can out of our systems, we take advantage of this temporary storage. The downside is you lose power, system locks up, whatever information is there is gone. So there needs to be specific ways that information is periodically backed up to permanent storage and so forth. So the secondary storage is that backup storage, that permanent storage that you can access whenever. Traditionally, that's been with hard drives. And hard drives were physical devices that had a disk inside of the drive that was coated with magnetic material, and it would spin at high speed, and you could, with recording heads, record data onto the magnetic surface and then retrieve it. And that was really what was used for a long time, until we have this idea of solid state hard drives. And so what they were able to do is take that temporary storage, those RAM chips, and figure out with technology a way that they could permanently store information to it, so that when you lost power, you didn't lose the data, it stays. The advantage of a solid state drive is that they are much faster than hard drives. They are a lot smaller than physical hard drives. And there's indication that they are a lot more reliable. They can go for years without issues. Hard drives, being a mechanical device, they do go bad after a period of time. Now, I will say, solid state drives do not last forever. They have a maximum number of times that you can read and write to that memory locations, that memory cell, and then it starts to degrade on you. So they're not forever, but they are more reliable than traditional hard drives. And the prices have come way down now. So there's really, when you're buying a new computer these days or a new laptop, everything is solid state hard drives, or they call them SSDs. And then the last one is really this idea that we're not going to store the information at our physical location. Instead, it's actually going to be stored up in the cloud. Well, how does the cloud store that information? It stores it on permanent, hard drives and solid state drives. So it just moves the physical location. Instead of being at our location, it's at some location, who knows where. Could be anywhere around the world. And with good cloud storage systems, it's stored in multiple locations in different geographic areas so that a single geographic issue, a tornado, a snowstorm, wildfires, doesn't take down the cloud storage, because there are duplicate copies located in different areas around the world. And so it's seamless. As a user, you don't know that anything happened to one of those facilities, because it just automatically switches over to one of the other sources for that information. So one of the things that gets talked a lot about, and what I like what the author did here, is to put some context to when you hear terms, kilobytes, megabytes, gigabytes, exabytes, okay, that's a number of digital bits, that are stored. Kind of the funny thing is, in the digital world, when we're talking with computers, a bit is a single piece of information. It can have only two values. It can be a 0 or a 1. Now, if you put those together, you combine them, then you can get a word that's 8 bits of information. You can also then take and do half of that, and then that's called a byte. And when you further take half of that, this is geek humor they came up with, the term is a nibble. But anyhow, when someone talks about kilobytes, that's what we talked about for storage in the early days of computers. You talked about kilobytes of memory, kilobytes that you could store on a floppy disk. I remember when the Apple first came out with a 3.5-inch kind of hard floppy drive, and it could store a whopping 1 megabyte of data, and it was so impressive. It's all relative. But anyhow, a kilobyte, as the author says, you could do a short email message and use that. Look at a gigabyte. That's about 1 hour of TV recording. And the one that's interesting is an exabyte. So 11 million movies in 4K format, to give you an idea of the data. And what we're talking about is, on a global basis, there is an excess of 1 exabyte of new data created every year. And the problem we really have, and we'll talk more about this in a later chapter, how to deal with this. The problem is not that we don't have data available. The problem is we have so much data available, it is hard to find the small piece that you're looking for. When there is so much new data being produced all the time, it literally, we are looking for, when we do a search, we're looking for a needle in a haystack. It's not very helpful when you do a Google search on something and it comes back and it says there were 953,000 hits. No one's going to go through 953,000 websites to find the one you're looking for. So how do we deploy and develop our infrastructure within an organization? So there's really, there's only a couple of different ways that we can approach this. The first one is we could buy, with the commercial version of the software. So you could go into a software store. I don't think they have those anymore. I think everything is ordered online. But you could buy a physical copy or download a copy of a particular application that was developed by someone. You have very little ability to customize it or alter it. It is what it is. And that's certainly from the start of our computer systems in business, that's what we were primarily using. It was something that someone else had developed, and we evaluated it and said, yeah, that should work for us. Now, the next way is what's called software as a service. And what we mean by this is we don't buy the software and install it on our computer. Instead, we license it. A company gives us permission to use that software for as long as we pay the annual fee. And a lot of software has been moving that way. Even Microsoft Office, you can still buy a lifetime, license. You buy it once and you can keep it forever. But they've really moved, as have most software publishers, to this idea of you pay an annual fee in order for the software to work, and you have to keep renewing it. Now, you could also develop your own software. Now, because the only reason you would do that is if you did all your analysis and you find out that, gee, there isn't anything out there that exists today that does what we need it to do. And so then you're stuck having to develop custom software. When I worked for the local company, Precision Interconnect, we had a need to do some automated testing. It was very specific. We had a robotic arm. We had to move a test probe around to specific points to do this. And there wasn't any software to do that. So we had our test engineer that wrote our own custom software for it. Now, it's expensive to write your own software, and you have to go through a lot of test and debug when you do something like that. And we did. And he didn't get everything right the first time. There were a few times where illegal commands were issued to the servo motors, and it did what we call the seek to the moon move, where it would slam the motors and go to the vertical stop. It would hit it so hard we thought it was going to break the metal stops. So custom software should only be approached if there is no other way to do it, because there's a lot of maintenance and update issues. There's a reason why software companies are out there, because they've got a staff of people. They, are analyzing it for problems, coming out with updates and stuff. And it's expensive for most, especially smaller companies, to develop their own software in-house. Now, a number of the software service companies, I will comment on this, will gladly, for a fee, customize the software to work differently for you. And later in the course, one of your assignments will be to look at ERP implementations. ERP is it stands for Enterprise Resource Planning, and it's software that runs virtually all the different aspects of your business. And they are configurable, customizable. Where a lot of companies got in trouble and they ended up having failed ERP implementations is that they tried to make the software match their current business processes. And the best results are when you update and modify your business processes to match the software. Having custom software developed by a company is expensive, and if you're not careful with the information you provide them as what they want it to do, it can be a real disaster. So my recommendation is, as much as you can, use the as-is version of any software with minimal, if any, customizations for your company. Instead, figure out how to make your company work within the standard software. Another thing that the software as a service has been transitioning is to go to web-based applications. So instead of actually physically installing the software or downloading the software onto your computer, instead, you go to a web site and you use the web-based version of that. Now, like with Microsoft Office, there are web-based versions of Word, Excel, and PowerPoint that you can just operate from your computer. You don't have to have the software installed at all. And we're seeing more and more of this. And one of the reasons for that is that it makes it very easy then for whoever the software supplier is, when they need to make an update, a feature improvement, or they found a bug or they found a problem, they only have to do it in one place. You don't have to update your machine because you don't have it running on your machine. You're just accessing their version that is running on their server by going through the web. So it does really help to keep all your software updated and any security issues addressed by using web-based instead of installing it on a computer. So how do we communicate within our organization? There's two ways, only two ways of moving stuff around, right at the moment at least. That's either through wires or through wireless. And so let's look at that a little bit more. When we're talking about wires, the first thing is what's called twisted pair. And this is where you take some copper wires, you twist them together, and you do that because when the wires are twisted together, it tends to cancel out some of the noise that's introduced from any electronic devices nearby that can generate EMI, electromagnetic interference. And this was first developed to use with telephones. And it's nice, it's simple cable, it's what your traditional network cable, let's call a Cat6 cable, that, you know, when you plug your computer into a jack on the wall, you're using what this picture is. It shows there's 4 pairs of wire in the cable. The cable can be very flexible, and it's pretty easy to terminate, to repair if you need to replace the connector, and it's inexpensive. But the problem is it's a small wire, and that affects how far a signal can be transmitted over the wire. I could go into the details and tell you why that is and what's going on, but that's getting into engineering and physics, and that's a little beyond the scope of this course. But suffice it to say, the smaller the wire, the shorter the distance it can go before the signal is just, there's nothing left. It gets less and less and less. And the other, because of that, that means there's a limit on the distance that you can run a signal over that. Now, the way we get around that within buildings and so forth is that you can put in a repeater. So you can have this cable go to, you know, you reach the maximum distance that you want to safely operate within. It can be received by a digital circuit and then regenerated and sent down another wire and go another distance. And so you can have a series of repeaters to boost the signal back up, to take into account the degradation that has occurred over distance. But the bandwidth is still going to be limited by the size of the wire. You just can't go fast. Even shorter distances, there's still some physics involved in how electrons work on copper wire that prevent you from going as fast as we would like to in today's world. Now, one way for getting around that is to use, instead of the multiple twisted pairs like you see there, is to use a round cable. It's called a coaxial cable. This was first used by cable TV to get higher bandwidth than a traditional phone line could provide. So as cable TV started implementing, subscription TV and installing things, this was the transmission of choice. It is, if any of you that have had a cable TV and the cable that goes from your TV to the wall, It's much larger, about the size of my little finger in diameter. It's stiff. It's not nearly as flexible as the network cable. And replacing a connector on the end, it takes special tools to be able to strip the wire. You can see what this picture shows here at the top is, you can make an initial strip, but then you can see that third picture down. You see there's the center conductor, that's that copper kind of orange color, and then a white that's an insulation, and then there's a braid that's around it, and then the black is the jacket. You have to get it to that uh, condition before you can attach the connector. It goes on the end. So it's a little bit more of a challenge to replace a connector, or if the cable gets damaged and you want to cut the damaged part out and put in some replacement connectors. But it does have much higher bandwidth than the twisted pair. But it suffers from the same problem that the twisted pair does. It's sending electrons down a piece of copper, and the bandwidth it's limited by the physics involved in doing that. And as you go over a distance, the signal gets weaker and weaker. You can, just like with the twisted pair, have repeaters installed and boost it back up. That can allow you to go longer distances, but it doesn't address the bandwidth issue. It's still going to be limited by the physics of electrons and traveling down copper wire. What is the better solution now, and we're seeing more and more implementations of this, is not to transmit information using electricity by sending electrons down a copper wire, but instead to transmit light down cables. And the fiber optic cables are made of very thin pieces of either glass or plastic. And the interesting thing about this, you would think, oh, gee, a strand of glass, that's got to be very fragile. Actually, not. They've got some very interesting manufacturing techniques that it's a pretty robust cable, and it can be very flexible. It can be very small. So instead of being the size of my little finger, it can be the size of a pencil lead. And it allows it to be very flexible. But the key is you can go for a very, very long ways with no apparent degradation in the light that's coming out the other end. And the speed of light is 186,000 miles per second. So your signal gets to the other end extremely quickly. And what that allows you to do is to transmit at a much higher bandwidth than you can with copper wire. And they can do some interesting things with the fiber optics and sending multiple signals down the same piece of transmission glass or plastic. And they do that by transmitting the light at a different angle. Because the way the light travels down the fiber optic cable, it's not a straight shot. And in actuality, the light goes up and hits the one edge and bounces down, hits the other edge, bounces up and down, and it keeps doing that all the way down. And so if you change the angle at which the light is transmitted, this is one signal. Now you make another signal that's a little less, another one that's a greater. You can actually transmit multiple signals down the same wire, and at the other end you can separate them apart. So you can get a lot more throughput in the same cable. Sounds great. Why isn't everything done in fiber optics then? And it's strictly a matter of cost. In order to transmit that light down the fiber optic cable, you have to convert the electrical signal, because computers, all our technology works on electrons, electricity. Everything is based on that. So in order to transmit information, we first have to convert it from the electron domain to a photon domain. And currently, the cost of that conversion circuitry, it's costly. It's much more expensive than just going down the wire. And so presently, the fiber optic is primarily used for very long runs. For shorter runs that can be done with copper and get acceptable bandwidth and performance, it's a much better cost solution. Now, we'll continue to see that change as technologies are implemented, better ways of doing the fiber optics. There are even some of the computer companies that are working on a optical-based computer, not an electron-based computer that all our current computers are. The advantage would be it would require very little power. It would generate no heat. So there's, stay tuned, more to come. There's a lot being worked on and developed, but right now we're seeing more and more fiber optics, fiber optics to the home, which is what I have. I've got 2 gigahertz of high-speed internet, directly to my house, and it's great. And we're seeing more and more of that being implemented all around the country. Unfortunately, it's limited to high population areas. You get out in the rural areas, you don't have access to fiber optics. You may not have access to hardly any internet at all. But anyhow, so the other way we can communicate, instead of a physical connection, whether that physical connection is copper or glass, we can go to wireless. And the way that wireless works is to take a carrier signal, and it's the same principle that works for radios. Radios take the audio waveform, the sounds, the music, the voice that you want to transmit, and that information rides on a carrier, and that's the FM 101.1. That's the carrier frequency that the information is transmitted, it's packaged with. We could go into all the details how that gets done, but again, that's more in-depth than the point of this course. But just to understand that when we're talking about wireless, whether it's our cell phones, our laptops, that's using RF technology, radio frequency technology, to transmit that information by encoding it onto this radio frequency wave. Now, to get the bandwidth we want, and so that it doesn't interfere with radio stations and TV stations, they do go at a different frequency, and it's at a higher frequency, a microwave transmission. The higher the frequency, the more information, more data you can transmit. But the higher the frequency, the shorter the distance that it will go before there's no signal left. And so they're just like we were talking about with the wires and having repeaters, you have to have microwave transmission repeaters. So one microwave antenna is pointing to a receiver that then turns around and broadcasts it. So you keep boosting the signal back up. You may hear the terms Wi-Fi and Bluetooth. And again, it has to do with the frequency. Wi-Fi is a higher frequency that allows for much higher bandwidth. Originally, the Wi-Fi standard was kind of 2.4 gigahertz, but then they came out with 5 gigahertz and now 6 gigahertz Wi-Fi. And the reason for going to the higher frequencies is to be able to process more information, faster and quicker. Now, the downside is most of our Internet of Things smart devices, your smart doorbell, your security system, your light controller, your refrigerator that tells you when it's time to order milk, most of those only work with the lower 2.4 gigahertz protocol. And you can have some challenges getting those set up. So, but computers and laptops or cell phones will automatically switch between the 2.4, the 5, and the 6, whichever signal is best they will use. Bluetooth was developed as a way of communicating computer devices so that, like you see my mouse here, there's no wires on it. How is it communicating with my computer? It's using Bluetooth. And so Bluetooth was developed just as a way of getting rid of the connecting wires on the computers. And the items that they were connecting, like a mouse, that's not a lot of data and information transmitting at any time. A keyboard, the same way, very slow rates of data. So it didn't have to have a high bandwidth requirement. So Bluetooth is at a much, much lower frequency, and it has a very limited range. Typically, only 30 to 40 feet for Bluetooth devices, whereas Wi-Fi, of course, you can go much farther with Wi-Fi than you can with Bluetooth. Skip ultra wideband. What I want to do is to talk about satellite internet. The solution that you're hearing a lot about between Elon Musk's Starlink and Amazon coming out with their own version of that, taking advantage of satellites as a way of providing internet access, high-speed internet access to people, particularly in rural areas that don't have access to high-speed internet. And there are parts of the world where there just isn't the infrastructure in place to be able to provide good internet access to everyone. So really the vision with the satellites is creating a satellite network where anyone, anywhere in the world could, if they have the device and of course an account set up, tap into, excellent performance internet. Okay. And this is from the book. And what I just wanted to point out with this, a couple of devices, all the Internet of Things, those smart appliances that I talked about. This is the frequency range that they're operating in, way down at the bottom end. And then your microwave that's heating up your food is higher. And you can see radio and TV were in there. And then up here is what we call visible light. This is what we can see. And then this is X-rays. This is, in the medical world, when they want to see if your bone is broken, the X-rays that they're showing. And so that was just to kind of show you that there's a spectrum, but they're all the same thing. All of everything. In fact, let me back up on that. Everything you see on there falls under the category of electronic magnetic radiation. It's all the same. It's just the frequency, how fast, and that's what is shown by the drawing there of it goes up and it goes down and it goes up and goes down. How quickly is it changing? The number of times, the cycles per second, that's the definition of the frequency. And the electronic magnetic radiation, depending on how, fast that is changing the frequency determines what it is doing there. And you can see the higher it gets, the more dangerous it is. Certainly nuclear radiation is very harmful. X-rays you want to be protected from. You only get an X-ray if there's a medical reason to it, because the energy, and this is really the problem, it's the energy that is contained at that high frequency is enough to damage the structure of the cells. Lower frequencies, it doesn't have the energy and the capability of doing damage. So anyhow, moving on. So networking basics, you'll hear terms like local area network, or, LAN. That's just the devices that you have communicating within, basically your building, your office, the floor. It's just everybody's plugged together so they can talk to each other. Now the question is, how do they talk to each other? And there's this interesting concept of packet switching. Now I've included, you'll notice on this week, there's some supplemental videos listed in the content section for the course. And there's a nice video there. It was actually developed by Spotify that explains how packet switching works and how it has developed, this concept of packet switching, how it has allowed the internet to be so reliable, because it takes the information that we are sending and it breaks it up into little tiny pieces and sends all those individual pieces out on the internet, and the internet will route those to different paths depending upon the traffic. It knows where there's congestions, and so it will take alternate routes, much like you do. If you're trying to get from point A to point B in your car and the freeway is busy, of an alternate route using, local side streets to get you there. And so packet switching really allows that to happen. And to then at the other end, you don't even have to get the pieces in the proper order. You can get packet number 12, then packet 1, then packet 796, and then packet 17, and it will all get reassembled into the proper order. And if a packet doesn't make it, you can even send a request back to the sending unit saying, please resend packet 55. And so it's a really effective, efficient way of communicating across the internet. So I highly encourage you to watch that video. I think it's nicely done and really gives, I think, easy way of understanding that concept. Another thing you'll hear is VoIP, Voice over Internet Protocol. Now, the interesting thing is that people think this is a new thing that happened. Actually, the phone company switched to Voice over Internet Protocol back in the 80s. They were having problems. There was too much, too many people wanting phone numbers. They didn't want to keep having to string more and more copper wire all over the country. And so they started way back in the 80s converting our phone call to a digital format and transmitting that. And it's, in fact, the development of fiber optics came from the phone company because they wanted to increase the capacity without having to string a bunch more additional copper wire. And so they were really instrumental in implementing, developing that technology to do the fiber optics and use it for communicating voice data. But then, of course, everyone recognized very quickly, if you could transmit voice data over this, why can't you, communicate computer data over it? Data is data. It just, on the receiving end, you determine, does this get converted into an analog telephone call or Spotify music, or does it go to a financial program? So VoIP has really been around for a long time, but now more and more it's businesses and people use VoIP. And in fact, we have what traditionally has been called a landline at our house because we live in a cell phone dead zone. It's very unpredictable with our cell phone coverage where we live. So we have maintained a traditional landline, but it is no longer a copper wire that goes to a substation, for that. We're using VoIP. Our phone number is over our internet provider, which, as I mentioned before, I have 2 gig fiber optics coming to the house, and that's how our phone works. So the book has, you'll hear other terms like most common, what you'll hear is WAN or LAN. A WAN just means you're outside of a corporate area. It's covering an entire city kind of thing. And of course, a global area network, that's really, that's just the internet. So you'll hear those terms talking around. The two that you hear the most probably are WAN and LAN. So the trends, there's one thing that's true about the information in this course is the minute the publisher published the book, it was out of date. Things continue to change and evolve at a very rapid rate. So we can talk about trends, but knowing full well that tomorrow things are going to be different. But if we go back to the history in the 1960s, we had these large mainframes. The data center, would operate an entire room and had a massive air conditioning unit for itself. And then you had these remote terminals that connected to it. When I was in college, one of the computer classes I took, I would write a computer program and I had to create punch cards that I would then take to a data center and they would run the program. And then the next day I would go back and get a printout to see if my program ran correctly. We didn't even have terminals connected to the computer at that point. But then that transitioned to where we have a lot of smart devices, our desktop computers. And in that case, our desktop computers were doing all the work, and primarily the mainframe computer systems that we had were just the data servers. They were providing a warehouse, a location for everyone in the organization to be able to access the information. And of course, now what we're seeing is that that's been replaced with cloud-based solutions for that. And we're back to using just dumb terminals that access the cloud systems through the internet, through a web browser, and the computing is all being done on the cloud-based server, and the data storage is being done there. So stay tuned. There'll be new changes, I'm sure, as we continue to go forward. We'll talk a little bit more about cloud storage. But one of the things I did want to mention that has been, and this came about really from the pandemic. When we talk about trends, it's BYOD, bring your own device. What a number of organizations has realized is, why should the company provide a particular device to you and say, this is what you have to use? The big, obvious example of that is there are some people who prefer using a Mac, some people prefer using Windows. Why should the organization care if you use an Apple device or a Windows device, since it's all being performed, the computation is happening on the web in the cloud server? And so a lot of organizations like I said, because of the pandemic, adopted policies where individuals could use their own device of choice. Now, there's a lot of caveats that go in with that. You have to have the proper security software installed on your device. There's certain limitations and structures around that so you can protect the organization's data, but they really opened up some flexibility for you to choose which device you wanted to use. And even as I talked about using websites and in the cloud, another thing that's happening now is that instead of using those websites, so instead of going to Amazon.com as a website, there's more and more use where people are using the app for Amazon, not the website Amazon.com. And there have been some studies that show that people prefer using apps rather than going to corporate websites. That presents a whole number of challenges and issues, because a lot of times the way that people are accessing those apps are through a mobile device, a cell phone or a tablet. And certainly with cell phones, the big issue is the screen size. How can you convey the information that that person needs and wants to see in that small screen? But that is a trend that is happening more and more. We're seeing people are preferring the apps over websites. I already talked about that, getting away from installing software on your devices, instead using web-based applications. And a good example of that is the Chromebook. When Google first came out with that, it was the idea that you don't need to have all this storage on your computer to install software. Instead, let's just utilize the software on the cloud, on the internet, to run the applications. And by doing that, Chromebooks cost significantly less than a full-featured tablet or laptop. Now, the downside is Chromebook only works if you have connection to the internet. If you're in an area that doesn't have Wi-Fi, you can't get hooked up to the internet, the Chromebook is basically useless. There's nothing you can do with it. Whereas with a laptop where you have installed the software, if you don't have access to the internet, you can still use the software. And then when you can get connected to the internet, you can then upload or download to whatever you want. But devices like the Chromebook certainly provide a cost feature advantage to doing that. So I think we'll see more and more of that. Already talked about voice over IP. That really, it's this idea that voice, television, radio, financial, it's all just data. And it doesn't matter what form it is, it's just data moving over this interconnected web of communication devices. And so it's just all one thing. And what determines what is at the receiving end, but that the idea, we're just transmitting ones and zeros. And certainly, the trends are more and more clouds. Now, there's some challenges with that. And I think I've got a slide later where I talk about one of the issues is with the cloud is all those servers, because you have to have backup servers, you have to have multiple locations, they all require power. And our current electric grid system in the United States is maxed out. One of the fatal issues with electric cars that unfortunately the politicians didn't bother to do their homework. And a real issue is that there is no way that our current electric grid system can support having a majority of vehicles being electric. It's just not possible. We don't have the electric capacity. And more use of clouds is creating a further strain on the grid system. It's a major issue that no one seems to be addressing. I don't hear of any governmental plans or things in places on how to do a major upgrade to our infrastructure to support more, but we're creating all this additional demand. And so trends, I think, sadly, one of the trends you're going to see is that there are going to be rolling blackouts in major metropolitan areas. And it's just going to get worse and worse until the government finally has to do something, and then it'll take them forever to get anything done. So the trend I see is it's going to become a way of life that we're used to being up, power's down. And so I'll be moving on now to talk a little bit more about cloud computing. There are some really positive things about cloud computing. One of the great things is backup and recovery. As I mentioned, that cloud systems by nature, the data is not in one physical location. So if something happens, you have a fire in your building, you have an ice storm, you have a power outage, it doesn't have to mean that you don't have access to your data. It's somewhere else. It's backed up. Fortunately, when 9/11 happened and the two towers were destroyed in that terrorist attack, the two towers they destroyed were financial companies that were in there. And the majority of those companies had their local computers backed up daily to an offsite location. And so I know a number of the computer systems that were used were Dell computers. And after the attack, within a week, Dell had been able to provide to another location nearby exact setups of what had been in the buildings, at least the part that was using the Dell computers. And they were able to reload the data and access the data because the data had been stored elsewhere. So when you do have a disaster, having utilized cloud storage, it really protects you. You can come back very quickly and be back online. As you'll see, one of the assignments I have to look at how PCC dealt with ice storm when the Sylvania campus was without power. And you'll see that PCC, our IT department, did not understand this concept. And in fact, we did not have access to anything during the ice storm. One of the keys in the use for cloud storage is ERP systems. So I mentioned we'll talk more about this in a later chapter, and there's an assignment specifically about it. But the reason I bring it up here is that most ERP systems that are sold out there do provide proprietary cloud storage for the businesses using that ERP product. So the ERP system is running, it's a web-based application, and all of the company's data is stored somewhere else. So we're taking advantage of that cloud storage for businesses. Now, for smaller businesses, there may be, you may be running your systems on a local server, but then there are a number of companies that you can contract with to provide backup cloud storage for that, so that if something does happen to your physical server, you don't lose all that data. It's really essential to have that backed up. It used to be that periodically you would back up all your files and take it to offsite storage in a fire safe somewhere, so that you could restore things. The hardware store here in Tualatin, I want to say this was at least 10 years ago, it burned down. And they would, every few days, they would do a backup of their system in the store and then take it to an offsite location. So fortunately, they were able to reset up in a new location, temporary location, and they only lost a couple, 3 days of data. Now, if they'd been utilizing cloud storage, of course, they wouldn't have lost any data. But that's really what's key for business, is make sure you don't run that risk. So for you and I as individual users, there's a number of cloud services that you've no doubt heard about. iCloud, OneDrive, Google, Dropbox. I personally use one called iDrive. Has no relationship to Apple. They just chose that name. I use it because it has some additional features like remote PC access for troubleshooting family members' computers. But the point is, there's a lot of them out there, and they're very inexpensive, very affordable. So it's something you should look at to make sure that your important information is being backed up somewhere. So the challenges moving forward with the cloud drive, and there are some supplemental videos on the cloud storage in this for this week. I encourage you to watch those. They do talk more about cloud storage and the challenges with it. One of them certainly is security. You're storing very important information out there. Do you trust the company that you're working with, that they will protect your data and information, that your customers' data will not be compromised, your company's trade secrets will not be compromised? So security is an issue, and it will always be an issue. I already talked about the power consumption. These servers do use a lot of power. And another thing to think about is this company that you've got all your data stored with. What happens when that company goes out of business? Are you going to be able to access your data? Is it going to be tied up in the courts? It could be a number of issues around that. So cloud storage is wonderful, but like anything, it has its not so wonderful aspects as well. Key is just being aware of what those are, so that your eyes wide open, you understand, and put in to place a plan. You have developed a plan. What happens? What if this company goes out of business? Make sure you know what the answer is to that. And that's really the highlights of chapter 3, what I wanted to cover. Again, there's additional information in the book, so make sure you read that, the full chapter. And I'll be talking to you about chapter 4